Hello, distinguished viewers all over the world. Welcome to Simplified Maths Class. Simplified Maths Class it is. My name is Mr. Mike Omini, and today we'll be taking the topic probability. All right, so in probability, we're going to be handling a lot of probabilities, but in different slides. Today, we are going to be looking at the introductory part of probability, and then we'll be taking the probability of coins and the probability of dice. Then subsequently, we shall take the probability of cards, the probability of balls with or without replacement, and then we shall have the miscellaneous aspect of probability. Then we shall be taking also the Bayes theorem, Bayes probability distribution, the normal probability distribution, the Poisson probability distribution, and so on. But we'll be handling them in different slides. All right, so what is probability? Before we continue, if you have not subscribed to our channel, Simplified Maths Class, please kindly do that by clicking the red subscribe and on the bell notification. God bless you as you do that. All right, so we have probability. What is probability? The word probability simply means chance. Something happening by chance. It is a probability because it happens by chance. All right. So without waste of time, we have a formula we use for computing probability. And the formula is the probability of an event is giving us the number of required outcomes, all over the number of total outcomes. So whenever we want to look for the probability of an event, it is a number of required outcomes all over number of total outcomes. All right, so understand that probability is chance. The probability of an event that will never occur equals 0. Take note of that. The probability of an event that will never occur is equals to 0. For instance, if today is Monday, what is the probability that tomorrow will be Thursday? The probability is 0, because if today is Monday, there is a likelihood that tomorrow will certainly be Tuesday. And so the probability that tomorrow will be Thursday will not occur. Such an event will not occur. And so the probability of such an event equals 0. All right, so the probability of an event that must occur equals 1. The probability of an event that must occur equals 1. All right, so say for instance, if today is Monday, what's the probability that tomorrow will be Tuesday? If today is Monday, definitely tomorrow will be Tuesday. And so the probability that tomorrow will be Tuesday equals 1. Because whether you like it or not, as far as today is Monday, tomorrow will definitely be Tuesday. And so the probability of an event that must occur with certainty, it is 1. Now, the probability of an event that may or may not occur will definitely lie between 0 and 1. That is why in probability, your result must always be normal fractions, because every normal fraction lies between 0 and 1. Say for instance, if you have 1 all over 3 or 2 over 3, or let's say 25 over 58, 9 over 70, 100 over 257. These are all normal fractions. We are not talking about improper fractions, of course. These are all normal fractions, meaning that the values of every normal fraction lies between 0 and 1. And that is the values we are expected to have during probability distribution. And of course, you should know that the lowest limit for probability is 0. And the upper limit for probability results is 1. And so every other event that may or may not occur will lie between the 0 and the 1. So anything below 0 is not probability, and anything above 1 cannot be probability. So your probability results will lie between 0 and 1. And in most cases, our fractional answers will always lie between these two extreme values. The lower value for events that can never occur, and the upper value for events that must occur. Please take note of that. All right, so we are going to go straight to the topic, probability of... Okay, so we'll take first probability of coins, and then after that we'll take probability of dice. That's the type we'll be taking today. All right, so for coins, take note, if a coin is tossed, the outcome is either you have a head or a tail. When once you take a coin, an unbiased coin, and toss it once, the outcome is that you either have a head or a tail. So what is the probability that in a single toss of a coin, the outcome will be a head? The probability that when you toss a coin, the head will be the outcome will be how many heads? Remember that we say that probability has to do with number of required outcomes all over number of total outcomes. So the probability for head, the required outcome is a head, which is 1, all over the total outcomes, head and tail, which of course there are 2 events. So it means that when you toss a coin, the probability that the head will appear will be 1 over 2. Why? Because the required outcome is a head, and a head is just 1 event. All over the total outcomes is either a head or a tail, and these are 2 events, so you have 1 all over 2. The same thing with the probability of a tail appearing in a single toss of a coin. Definitely it will still be 1 all over 2, because for the tail we only have 1 tail, and for the total outcomes you have head and tail, which is 2. And of course, number of required outcomes is the tail, which is 1, all over number of total outcomes, 2 items, which is 2. Please take note of that. All right, so if we are to go into a coin being rolled twice. Now, if a coin is tossed twice, that is, if you take a single coin and you toss it twice, or you take 2 coins and toss it once, you're expected that the outcomes, the possible outcomes, will be either a head appearing, or a head and a tail appearing, or a tail and a head appearing, or a tail and a tail appearing. So anytime you take 2 coins, 2 unbiased coins, and toss it once, the possible outcome is that you either have a head, or a head tail, or a tail head, or a tail tail. But you should understand that a head tail and a tail head are 2 different events. It means that here the head appeared first before the tail in the second toss. But here in the first toss, it is the tail that appeared before the head in the second toss. So there are 2 different things. So if a coin is tossed twice, the possible outcomes will be this. Now, what is the experimental probability that in a single toss of, or in a single toss of 2 coins, that the outcome will be a head tail? The probability of a head tail, the number of required outcomes, head tail is 1 outcome all over total possible outcomes, which is 4. So you have 1 all over 4. All right, so what is the probability that you will have a head tail or a head? All right, take note of this. If 2 coins are rolled once, or if a coin is rolled twice, what is the experimental probability that the outcome will be a head tail or a head? And of course, a head tail is 1 out of 4, or in probability means we add a head is also 1 out of 4, because there are 4 possible events. So 1 over 4 plus 1 over 4 will give us 2 over 4. And of course, 2 over 4 will give us half. Please take note of that. So if the coin is also tossed twice, what is the experimental probability that you have at least 1 head, at least 1 H appearing? Now, if these 2 coins are tossed once, or a coin is tossed twice, what is the experimental probability that at least 1 head will appear? At least 1 head, meaning 1 head or more. At least 1 head. So here you have more. Here you have 1 head. Here you also have 1 head. So the experimental probability of having at least 1 head, meaning 1 head or more, will be 3 outcomes out of 4 outcomes. So the probability of at least 1 head will be 3 probable outcomes all over a total outcomes of 4, which is 3 all over 4. All right, so that is when a coin is rolled twice. So these are the kind of problems you meet when you're dealing with a coin, the probability of coins, a single toss of coin or a double toss of a coin. All right, so what about the die, probability of die? All right, so we are going to take a dice, probability of dice. All right, so when we're dealing with dice, we mean an unbiased die, a die or a die. So when you have die, it is one. The plural is D-I-C-E. So that is the plural. So one is a die, two is a dice, two or more. All right, so what to take probability of a die? All right, so if you have a single toes of a die is that particular object that is used in playing the Ludo game that has a numbering from 1 to 6, you know, imprints 1 to 6. All right, so in a single toes of a die, you expect that the possible outcomes in the toes of die will either be 1 or a 2 appearing, or a 3, or a 4, or a 5, or 6. So a die is like a cube. It has 6 sides, it's 6-sided. And the outcomes there is 1, 2, 3, 4, 5, 6 on each side of the die. All right. So if you toss a die, the experimental outcome is that you either have a 1 or a 2 or a 3 or a 4 or a 5 or a 6 appearing in a single toss of a die. All right. So if a die is rolled, what is the experimental probability that the outcome will be a 2? Okay, so the probability of a 2 appearing, 2 is one event out of a total event of 6. It's that simple. Now the probability of an odd number appearing, in a single toss of a die. An odd number appearing, meaning that either 1 will appear, or 3 will appear, or 5 will appear. That's what it means. So the probability of an odd number appearing will be, how many odd numbers do we have? 3 out of the total possible outcomes, which is 6. So you're going to have 1 all over 2 as your answer. It's that simple. All right, so if you toss a die, what is the experimental probability that 2 or an even number will appear? What is the probability that 2 or an even number will appear? All right, so we have 2 or even numbers. Even numbers there we have is 2, 4, and 6. 2, 4, and 6. So what's the experimental probability that 2 or an even number will appear? Notice that 2 here also appears in the even numbers. So it will be repetition for you to double count the 2. So the probability of 2 or an even number appearing will be equals to 1 event, 2, and 3. So that will be 3 possible events out of a total event of 6. So that will be 1 all over 2. It's that simple. But watch the next one. If you toss a die, what is the experimental probability that, let's say, 4 or a prime number will appear? 4 or a prime number will appear. All right. So 4 or the prime numbers we have in a single toss of a die will be 2 is a prime number, 3 is a prime number, and 5 is a prime number. So 4 on 2, 3, or 5. Because the prime numbers we have are 2, 3, 5. And then they say, what's the experimental probability that 4 or a prime number will appear in a single toss of a die? All right, notice that 4 is a different event. 2, 3, 5, which is for the prime numbers. They are different events. There is no repetition of an element here. It therefore means that the probability will be 1, 2, 3, 4, 4 outcomes all over 6 total possible outcomes. And that will give us 2 here, 2, 2 here, 3. Always notice that we express our probability in simplest fractional forms. In the simplest fractional forms after reducing them to the lowest values. And like as I've told you, every probability result you have will definitely be between 0 and 1. We'll have normal fractions of probability. We are not expected to have improper fractions in probability. And so we've been able to do that. All right, so in our next slide, we'll be taking the probability of dice, which is when a die is rolled twice or 2 dice are rolled once. And then before we can go into probability of cards, probability of balls with or without replacement, the miscellaneous probability that has to do with flowers, this, that, different things. And then we can now go into the Bayes probability distribution theory, and then the Poisson probability distribution theory, and then finally the normal probability distribution theory. So please don't forget to subscribe to our channel, Simplified Maths Class, so that you don't miss out in any of these important aspects of probability. But if you've already subscribed, thank you very much. You can give us a like. All right, please give us a thumbnail. But if you have any question whatsoever, don't forget to drop it in the comment section and we'll respond to your question. God bless you. See you in our next slide. Probability of balls and of cards. God bless you.